Now, before we'll continue working with structs and practice working with structs, there's one kind of related thing I also want to mention here. Because of course in this section we created our custom struct type, and that is a very common type you will create, and we, for example, also added methods to that struct. And again, that's typically something you'll do quite a bit when working with Go. But it turns out that in Go you can use this type keyword not just to create custom struct types, though that's probably how you will use it the most, in conjunction with the interface type, about which you will learn later. But you can also use the type keyword to assign an alias, you could say, to other built-in types. And you'll see why you might want to do this in a couple of minutes, and also again later in the course. So let's say we want to create our own version of the default string. So I'll name it custom string, but the name is up to you. So that's the name for my type, but now after this name, I don't add struct because I don't want to define the blueprint for a struct here. Instead, I now use the built-in type, string for example, for which I want to assign an alias. Now in my application, I can use my own custom type here, custom string, instead of the built-in string if I want to create a variable that should be of type string. And that doesn't sound like a good idea. I mean, what do we gain by doing that? Now it's longer than the default string and it's exactly the same type. Well, of course, theoretically, we could have chosen a shorter name, so we would at least save some characters. That's something we could do. But still, this might not make too much sense, because in bigger programs it might not be obvious that str refers to the built-in string, and we would have to look up what's behind that alias, so just using string would typically be a better idea because it's clear which kind of value we really want here. Nonetheless, you can create such an alias, and later in this course, once we dive into arrays, slices, maps, and functions as values, you will see better use cases for assigning an alias to a built-in type. So use cases and examples where this makes more sense. Here it doesn't make too much sense like this. But it makes more sense once you know that you can then actually also use your custom type to assign methods to it. So functions that are attached to it, just as we did it with the struct type. Here we could add a log function and then add this receiver argument about which you learned, and then use our own str type here. We, for example, couldn't use the built-in string type. Here I'm getting an error that I can't define new methods on that non-local type string, so on that built-in type string, you could say. But I can add a method to my custom type, even though under the hood that custom type simply refers to the built-in string type. But you could say that Go builds a copy of the built-in string type for you under the name str, and you can then add a method to that. Well, and then here we can also assign a name to that received value, and the received value will be the string on which we then call log. And we could then use the FMT package, for example, to output text here. And now we can use our custom type to create a variable with that type, and then of course also assign a value. And here I don't want to do that in one step, because if I would do it in one step, Go would of course infer that name should be of type string, because this here is a string. Therefore, if I want to force Go to use my own custom type, we have to explicitly set our own custom type and then assign a value. Though we could of course still do that all in one line if we wanted to, but this type assignment here is important. And once we did that, we can use that variable and call this log method, which then would trigger this code here. Therefore, with that, if you now run this application, you see max here in the console, in my case, because of that custom type and that method we created here. And of course, you can assign such a type alias to any built-in type. We could do the same for int or float64 and so on. And as you will see later in the course, as mentioned, you can also create such type aliases, such custom types, as I call it here, for more complex built-in types. But again, I'll get back to that later.